Okay, today we're working on 6.6, finding the equation of a line given 2 points. And let's just start working with this first problem here as a warm-up. An isosceles triangle and a square have the same perimeter. Find the side lengths of the triangle. First thing we know is that the square has equal side lengths, so of course all side lengths are 4. So 4 times 4, or 4 plus 4 plus 4 plus 4 is 16. So we know that the area of that square is 16 units. The isosceles triangle, on the other hand, has 2x plus 1 here, and then this side of the isosceles is also 2x plus 1. Then we are going to add the side lengths of the triangle. We have 2x plus 1 twice, so the easy way to do that is to write it like the distributive property, 2 times 2x plus 1, because we have two of those, of course, plus 3x, which is the base. Then we are going to use the distributive property to expand and simplify. So we have 2 times 2x is 4x, and 2 times the 1 is 2. And of course we have plus 3x equals 16. 4x and 3x get us 7x. And if we take this 2 and send it over, or subtract 2 from both sides, we get 16 minus 2, which is 14. 7x divided by 7 equal 14 divided by 7. So all we're doing here is dividing both sides by 7, and we find out x equal 2. Remember, the question asks us to find the side lengths of the triangle. Well, if x equal 2, we can find the side lengths of the triangle. We know that the first side length, or the two side lengths that are equal, are 2x plus 1. So therefore that equals 2 times, I'm going to sub x equal 2 in for that there, 2 times 2 plus 1. And that equals 4 plus 1, which is equal to 5. So the side lengths are 5, 5, and 3 times x, which in this case is 3 times 2, which is 6. So the side lengths are 5, 5, and 6 units. If you add 5, 5, and 6, you get 16. And of course, the square has a perimeter of 16, so we know those work out well. They're equal. So the learning goal here is to determine the equation of a line given 2 points with pencil and paper, and also trying to use technology or your graphing display calculator. So let's first use pencil and paper, or the method that you should be familiar with from last day. All right, so we've got 2 points, P, 2, 3, and Q, 5, 6. Very first thing we want to do is find the slope. We know the equation for slope is y2 minus y1 over x2. Let me fix that. X2 minus x1. And that'll equal 6 minus 3 as my y coordinates, and 5 minus 2 in the denominator, and 6 minus 3 is 3, 5 minus 2 is 3, and that equals 1. So far I know that my equation is y equal technically 1x and then plus b. We don't have to write this 1 here because that would be bad form. We know there's a numerical coefficient of 1 in front of the x if we write it like this, y equal 1x plus b. If there were more than 1x, we'd say 2x or 3x or negative 2x, etc. Okay, now to find what the y-intercept is, we want to sub in either p or q for this. So let's sub in, I like to sub in 2, 3 because there are smaller numbers to work with. Remember, the 3 has to go here for the y. A common mistake is plugging in the 2 first because you see it first, but we need to remember that the y value of this coordinate is 3, so that goes in for the y. And then the x value is 2. So y, 3 equal 2 plus b. If we subtract 2 from both sides or bring this over, we get 3 minus 2, which is 1. So 1 equal b. I can show you the step for those that need to see it. 3 minus 2 equal b, and then 1 equal b. Therefore, the equation of our line is y equal x plus 1, or 1x plus 1. If you're going to find the equation of this line using your GDC, your graphing display calculator, what you want to do is, I'm going to let you do this on your own. I'm not going to walk you through it completely, but I'll give you a hint. You want to go to your stat menu, don't forget. So you want to go to stat menu and you want to edit it. You want to edit your stats and you want to enter 2 and 5 under list 1. And under list 2, you want to enter 3 and 6 respectively. And then when you graph, if you go to zoom 6, which is zoom standard, you'll get your standard window, and that'll make automatically 10 by 10 by 10 by 10. So this will go up to positive 10 here, negative 10 there, positive 10 here, and negative 10 there. And if you graph this properly, remember to turn your stat plot on. How do you do that? You go to the second function, y equal, and turn your stat plot on. And you want to make sure that you don't have anything. When you hit y equal all by itself, try and see if you have anything else there from the last time you used your calculator. You may have a line or something you graphed, something we've done prior. So hit y equal and delete anything that's there, and then hit second function, y equal, and turn your stat plot on. If you hit graph, you should see a little square here and a little square there, something like that. And then you want to calculate a linear regression, and if you do that properly, you should get a line that looks something like that. Okay, so I'll leave that to you, and if you need some help, please come see me. For this question here, Anil's family is driving home to Toronto. Anil hopes that they will make it back in time to see the hockey game on television. While traveling at a fairly constant speed, that's important that we have the word constant there. That means they're traveling consistently, so that would be a linear relationship or a straight line. He observes two signs along the trip. So keep in mind, this is the first one he sees when leaving home, and then at 4:30, and then at 7 o'clock he sees this sign. How fast is Anil's family traveling? Well, we know that distance is equal to, sorry, I apologize, speed is equal to distance over time. So the distance you travel over a certain period of time can tell us how fast you are going. For example, if you travel 240 kilometers in 3 hours, then we can say that you are traveling at approximately 80 kilometers per hour. In this case, we know that Anil's family traveled, they were at a distance of 240, and then they were at a distance of 40 kilometers away. So at 4:30 p.m., from 4:30 p.m. to 7 p.m. is 2.5 hours. So the time we know is 2.5 hours. And for the distance, we're going to say that it's actually 40. So the way I got 2.5 is I did 7 minus 7 o'clock minus the 4:30 basically. And then for this, I'm going to say 40 minus 240, which is negative 200. So 40 minus 240 is negative 200. And of course, if you want to use an easy breezy calculator, you can say 200 or negative 200 divided by, that's not what I wanted to do. You can say, sorry, negative 200 divided by 2.5, and that gives you negative 80. And neat calculator use. So your answer here is negative 80. The reason why it's negative is because on a distance time graph, you're actually traveling, you're originally at 240 kilometers away, and you're traveling to home, at which point then you'll have 0 kilometers to go. You reach your destination. So it's a negative slope. That's why we get negative 80 here. You're not traveling back in time. Okay, so how fast are they traveling? 80 kilometers an hour. So for A, 80 kilometers per hour. Find a linear equation that relates distance from home in kilometers to time traveled in hours. So the distance equal mt plus b. Same thing as saying y equal mx plus b, but we know on the y-axis we have distance. On the x-axis is time. That's the only difference. So when the question says find an equation that relates distance in kilometers to time traveled in hours, we want to use d and t. That's what it's asking you to do, just to see if you know what variable is represented on the y-axis and which variable is represented on the x-axis. So the distance in this case, the distance is going to equal to negative 80 t plus b. Then it says, so that's our answer to B. C asks us, the game starts at 7:45. Will they make it back to Toronto in time? If yes, how much spare time will Anil have to make it to the TV? If not, how late will he be? And what assumptions must you make? So when he makes it back to Toronto, the distance traveled has to equal 0, because as I showed you on that graph, when he gets to home, he's over here. At this point, he's 240 kilometers away. And then when he sees a second sign, he's here. And of course, when he reaches home, the y value will equal 0 at this point right here. If the y value is going to equal 0 when he makes it home, let's figure out when he makes it home. So we're going to say distance equal negative 80t plus b. When the distance is 0, we get negative 80t plus b. Excuse me. And we had, sorry, the y-intercept. We know the y-intercept is actually 240, so I could sub that in because we know that at the start, he was at 240 kilometers away. So that's our y-intercept. So we're subbing that in as well. And then we are going to bring this negative 80t over, or add 80t to both sides. I get 80t equal 240. We divide both sides by 80. And the time is equal to 3, or 3 hours. If the time is 3 hours, well, we know that he started traveling, it shows us here, he started traveling at 4:30. So 3 hours later, it will be 7:30. The game starts at 7:45 p.m. That's what the question tells us here. And so will he have time to make it back to the TV? Yes, he will. He'll have 15 minutes. So for C, yes, 15 minutes. However, it asks us what assumptions must you make. So the assumption we can make, yes, 15 minutes, if they travel at a constant speed of 80 kilometers an hour. So if they change their speed, of course, that'll affect when they get home. So the assumption you're making is that they continue to travel at that speed. All right, that's everything for today. We'll see you in class.